All right, we'll wrap up our last page of notes for this section before we do some good practice and a deep dive into practicing these lines. We can easily graph a line if it's in the form that we are familiar with, and that is our y equals mx plus b. And again, this is known as the slope-intercept form. Of a line because it tells us, guess what? It tells us the slope and it tells us the y-intercept. So again, we read those right out of the equation. The m, the coefficient of the x, that's our slope. And the b, the number hanging out by itself, that's our y-intercept. So if we're going to graph something, the first thing we do is we go to the y-intercept and we put a point on the graph. From there, we're going to rise and we run, making sure our line is going in the correct direction, remembering left to right going up is positive slope, left to right going down is negative slope. So here's an example. I want you to graph the equation y equals negative 2/3 x minus 3. So on the graph, first thing I do, I look for that y-intercept. In this case, it's negative 3. So on the y-axis, I'm going to go down 1, 2, 3, and put a point at negative 3. My slope is the number in front of the x. That's negative 2/3. That means my ratio of rise to run is down 2 over 3. Now people ask about this, where does that negative go? Does it mean it goes with the numerator or the denominator? Let's try both. We could do negative 2 over 3 or 2 over negative 3, and we should get the same thing. So if I start on that point and I rise negative 2, if I go down 2, and then a positive 3 in the x direction, 1, 2, 3, I end up here. I'm going to do that again. Down 2 over 3. And when you draw lines, I want you to fill up the graph as best you can, just to make sure you didn't make a mistake with plotting one of your rise to run ratios. If I went the other way, if I started at that negative 3 again, and I rose 2 and went negative 3 in the x direction, we can see we end up with that same set of, we call those collinear points, the same set of points all on the same line. That's that constant rate of change. It doesn't matter which one you call the numerator and which one you call the denominator, which one is negative. We get that rate of change anyway. So the next example here, we're going backwards. I've given you the line. I want you to give me the equation of the line. So I know it's going to be y equals something x plus something. I'm going to start with that y-intercept. The y-intercept is 1. That means I know my number here will be 1. It's going to be something x plus 1. Then I'm going to check the slope. So my rise to run ratio between those 2 points, the rise to run ratio, I'm going to go up and I'm going to go over. How many up? Well, let's see. From here to here, I'm going up 1, 2, 3 units. And going over 2 units. So my slope, 3 over 2. And it's positive, it's going uphill left to right. There's the equation of my line. Okay, I should be able to go back and forth between the equation and a graph. Slopes and y-intercepts. Just a reminder, if a line isn't in slope-intercept form, we can use a little bit of algebra to put it in that form. Here's this equation, 2x minus 3y equals negative 9. Not sure what that looks like. I don't know what the slope is. I don't know what the y-intercept is. Let me do a little bit of algebra. And again, the idea, let's isolate the y. So I'm going to subtract 2x from both sides. Minus 3y equals minus 2x minus 9. Notice that was a negative 9 to start with. And then to isolate the y, I'll divide everything by negative 3. And y will equal negative 2 divided by negative 3 is 2/3. X minus 9 divided by minus 3 is plus 3. So if I were to graph that line, I start at 3 on the y-axis. I go up 2 and over 3. Or I could go down 2 and over 3. The other direction, there's my line. And the second example doesn't look quite like it's not in standard form. It's not in any form that we're aware of. but I want to isolate the y. So first thing I'll do there is distribute. Y minus 4 equals 2x plus 12. And again, the goal here is let's get the y by itself. I would then add the 4, and I get y equals 2x plus 16, which would mean I'd have a y-intercept way up at 16, and my slope would be 2. Well, that would mean, again, up 2 over 1. Up 2 over 1. There is a 1 underneath that 2. Or I could go down 2 over 1 in the other direction. And that's what that line would look like. All right, so if it's not in slope-intercept form, we can put it in slope-intercept form. So a lot of big concepts here. We have the concept of slope, concept of line, the y-intercept, graphing, and going between different forms with lines using a little bit of algebra. Right, and we will pause there for the week. Check your Delta Math. You do have some Delta Math homework.